In this tutorial, we will use a boring bar to chamfer a centerline drilled hole on head 2 of a MAZATROL lathe. I'll start with the desired program open and ready for editing. All head 1 work has been done. The part has been transferred to head 2, where it has been faced and profiled to size. All that remains is to put a quick chamfer on the back of this drilled hole. Start by selecting turning. Next, select bar, then in. The cutting point X is the size of our drill, which was 1.5 inches. Cutting point Z is the back of our part at positive 6 inches. Since all I'm doing is chamfering a hole cut to size, I don't need a rough and finish tool, so finish allowance X and finish allowance Z are both 0. The control has correctly chosen a tool set up for cutting on head 2. I'll skip priorities for now and go right to cutting pattern. Since there is no back wall to finish, I'll use cutting pattern 1. Selecting the auto set coding L has given me a question mark for depth of cut and set my surface speed and feed rate. I'll leave the question mark for later and set coolant to off with an M9. For the shape data, all we need is one line with a starting corner chamfer of 0.10. Final point X is the size of the drilled hole at 1.5 inches. Final point Z just needs to be far enough in to allow the chamfer to be made with my 32 thousandths radius insert. 50 thousandths should be fine. 6 inches minus 50 thousandths leaves 5.95 inches. I don't need a final corner. And I won't change the finish feed rate. If I highlight the top line of the bar in process, I can zoom and rotate the graphic to inspect my work. There is one other important optional setting I want to examine. Since the tool is going to be working the back side of the part, I'm a little concerned about clearance as the tool approaches the cut. To demonstrate this, I'll put a temporary end unit on the program and go to Tool Path. I'll section the part, go to the ZX plane, and zoom to see the tool approach. When the tool approaches the part, the red triangle is representing the measured tip of the tool. You can see the tool is coming directly from the home position to a clearance position behind the part, and at a diameter clearing the outer diameter of the piece. These clearance values are set by parameters TC37 added to the diameter in X. In Z, it's controlled by TC40, with rough material and tool nose radius thrown in. When a boring bar approaches the back side of a part, the bar could strike on some parts. There is a simple solution to this problem. In the program, with program editing enabled, highlight the top line of the chamfering bar in process, and select TPC. In TPC, select the Relay Point tab. There are relay points for both rough and finish tools. With only one tool in the process, we only have to change the rough relay points. But remember, if you have both a rough and finish tool, you will have to change both. Scroll down to Rough Approach Relay Point, and change the setting to Manual. To make sure the bar clears the part, I'll choose a diameter well outside the diameter of my part. 10 inches in X should do. Leave Y-axis at 0. Using MAZATROL dimensions, I'll set Z to 6.5 inches, for a ½ inch behind the part. For the escape relay point, it's important to understand when these relay points take effect. They take effect when the tool moves to the clearance point after a cut. This means the boring bar will still be inside the bore. So, my first move in X must be less than the diameter of the bore. I'll use 1.4 inches. Leave Y-axis at 0. In Z, I'll again use 6.5 inches. Lastly, I'll bring the tool back up to 10 inches while still at 6.5 inches in Z. I don't need to concern myself with M codes or spindle speeds. Select TPC End to save the changes. If you've saved the changes correctly, you should see this blue plus symbol on the bar in process, indicating TPC has been edited. Going back to Tool Path, I'll inspect my changes. As desired, the first approach point is now at X of 10 and Z of 6.5. The control takes over and manages the cut from there. At the internal retract point, the tool now moves to the clearance point I programmed. Then up to 10 inches again, and the control takes over from there to take the tool home. With a few simple commands, I guided to tool into and out of the cut. However, the control still handled the actual cut. Returning to the program, I'll erase the temporary end unit, and I'm ready to continue programming.